And welcome to our actually last final technical presentation for 2023. It's good to see the amount of people here. So I'm just going to introduce the speaker. He actually needs no introduction, but so tonight's topic will be on the importance of surface preparation by Gert Conradie. And for the people that don't know me, I'm Petra Mitchell, and I'm Executive Director of the Corrosion Institute. So Gert completed his NACE, and also, sorry, the people online, can you hear me clearly?
All good. Thanks, Petra.
So welcome to the people online as well. I'm just also going to ask if there are somebody in the lobby, please admit it because we can't see it on our side. So if you can please assist us with that. So Gert completed his NACE peer review in New Orleans, USA, achieving his level 3 certified coatings inspector status in 2008. And it was Cathodic Protection Technician in 2013 after having undergone training he carried out several ball operations and Africa divisions, as well as inspection of coatings and linings of pipes and structures. As an appointed international coating inspector lecturer, Gert has conducted extensive lecturing for NACE or AMP. He was invited to the Asian Composite Educational Seminar in Thailand as a specialist guest speaker in Composite Repair Technology. Gert is currently employed by Cathodic Corrosion Engineering and continues to serve the corrosion industry. He is also a council member of the Corrosion Institute. Welcome, Gert.
Thank you very much, Petra. Good evening, everybody, and thank you again for turning up for the importance of surface preparation. I don't know if any of you ever Googled NACE. If you Google NACE and you put it in on the internet, it comes up as the National Association for Coating or Caterers Association. So I've actually had to change the whole concept of today's lecture because we're going to talk about catering. I'm going to show you how to chop up tomatoes. We're going to show you how to do a little bit of beet salad, broccoli. There's a little bit of all these other beautiful things. And if you're not one of the people that actually like the good, healthy food that we're presenting here, maybe you feel like a good burger. Right? So who's hungry? And here's the question. From what you saw there, did you eat the food presented to you on the presentation? You eat them. Or what if I told you that the food that you see there was prepared starting to have second doubts, maybe a little bit of a chipper for a couple of days, maybe even hospitalization. Let's not even say that we might end up in a coffin. The point being is that the food is prepared in a way right in the beginning, but what you see on the outside is something beautiful. You look at the food and you say, wow, that's scrumptious, that's delicious, I'll eat it. But what happened before that food actually got made? And this is exactly what we see. The preparation of the food in the area where that preparation took place, that's what's of utmost importance. So the same thing happens when we look at a coating system. Looks like a good coating, right? Looks very professional, everything that's happening. But what do we see on the outside? Beautiful paint. What's underneath that paint? We don't know. The point being is how was the surface preparation actually carried out? The same goes for this. That beautiful picture that you saw there could turn out something like that. And even though it looked nice and clean because you blasted the surface and you did everything in your preparation, but you left out one step. I didn't test the salts. Maybe I had some soluble salts on the surface. Therefore, having soluble salts on the surface, you have osmotic blistering, which is typical of the picture that is presented there. When we look at another picture, it's not as great. The conditions with beautiful spray booth, everything set up. Now we're outside, whoops, that's our burger. Now we're outside in the field. The compressor is starting knows what's really happening at the end of that spray gun. So our application on top of, if you agree with me. So what is the outcome of coating over a surface that hasn't been adequately prepared? Something like that. You paint over it, might have looked okay. You might have been convinced by coating suppliers, and I know I'm going to get lambasted afterwards. My coating is surface tolerant. You can paint over rust. Yeah, you can, but there's a certain degree. Where do you actually stop? How do you measure whether you've adequately prepared it before putting on your surface tolerant coating that you will sell to your people? And then it starts falling apart, exactly like a puzzle. Little by little, your paint starts falling off your substrate. It starts corroding in certain areas. Certain areas are more anodic, certain areas are more cathodic. So your paint starts falling apart. So hence, we actually now get to, and don't worry, we're going to talk about catering, the importance of surface preparation. Why is it so important for us to make sure that our surfaces are adequately prepared? It's a known fact that 90% of paint failures are due to poor surface preparations. And I think that's a known in the industry. It might even be more than that. Some people claim 75 to 80. The percentage doesn't matter. The point being is that if you don't adequately prepare your surface, what's going to happen to your coating? You're going to have failure that occurs. So surface preparation is key. And I specifically use the word key because when we prepare a surface, what do we want? Some form of a bond or adhesion between our substrate and the coating that we put on top. What if we're painting a mirror? Can we make something stick to a mirror? By all means. We all have it on our cell phones. Our screen protector, there's no adhesive applied to it, but you stick it onto the surface, it sticks. Why? Because of van der Waal forces. So there are certain elements that you could use and prepare a surface. But what did the guy do when you put on your screen protector? Alcohol swab, a little bit of dust that has to get removed. A lot of meticulous effort goes in, even placing something on top of a smooth surface. Now, when we go to metals, we need to remove certain elements off the metal. Might be mill scale, might be dust, dirt, oil, greases. All of those things that's on top of the surface, before we put a coating on top of it, needs to be removed. That's why I say surface preparation is the key. That's what unlocks the actual adhesion that we want on top of the surface. At the same time, it's quite a play on words, because we want to provide a key for our coating to hook into. Like an anchor profile, a rough surface. I like using the illustration of Velcro. Two surfaces, the one has got a little bit of hooks on it, the other one wants to stick to it. Once you put the two together, it's quite difficult to pull them apart. And the same applies to a metal. You take a metal and you start preparing that surface by making it rough enough. You provide that key between the actual coating system and the substrate that you're preparing. But for extended surface life, that keyed surface needs to be clean. We blast the surface with a lot of rough materials. In the old days, they used to call it sand blasting because they actually used sand. And because sand gave such a very good profile, it made the surface look and appear white. But what's in sand? All the minerals that we have that's in the earth. So all those minerals remain on the surface. Salts, it might be magnetite, it might be beryllium. You could go through all the elements that's actually part of soil. Clay, whatever it might be. That needs to be removed off the surface after you've blasted before putting a coating on, because it could have an adverse effect on your actual coating system, like we saw with the osmotic blistering. That's typical result that you get with salts that's left over. So a suitable roughness or key is typically also defined as an anchor pattern. That's the technical term that gets used in the industry. What is the anchor pattern? And we'll have a minimum and a maximum. And certain coatings like a rough pattern and other coatings like a very a lower pattern that actually gets adhered. Why is surface importance so important? Well, we don't just prepare steel. What are the other metals that we prepare? We prepare aluminium, zinc, copper, stainless steel is coated quite extensively. We coat concrete, we coat wood, we coat plastics. We think of our car bumpers. Most of our car bumpers are designed from some form of a polyethylene, but they make the coating stick to it. with the color coding of whatever the vehicle is. How do they make it stick? Surface preparation. Again, it's the key, it's the most fundamental element to make all of those items come together. So when we look at a bit of, not going to educate the corrosion engineers there, there's plenty of them here. When we look at corrosion of steel, you've got your ferrous compound, that's part of your metallurgical structure of your actual steel. It gets you into contact with the environment. Once you've got your 4 elements set up in your corrosion cell, anode, cathode, metallic pathway, electrolyte, you've got a corrosion cell. And which part of the metal corrodes? The anode. And on one surface, you can have an area that is more anodic than another area. And that's when a pit starts to form on the actual substrate. So how do we protect the steel? We blast it, we get it clean enough, and we put a coating on. But if you have a blob of dirt in one area on top of the steel and your coating doesn't stick there, you've now set up a corrosion cell. And pitting and corrosion starts occurring in that specific area. Or even worse, it starts creeping in underneath the coating and lifts the entire coating off the substrate, which can cause dramatic failures. What about stainless steel? Well, we design certain materials so that they can last longer, like a stainless steel, for instance. Ferritic stainless steels, 306, 304, and so forth. They like adding a little codes, LL, SL, PL, depending on the amount of chromium that gets put in, how much nickel they put in, how much molybdenum they put in, and they make it so that the metal lasts longer. And they call it corrosion resistant. But stainless steel is only as resistant as the passive layer remains on top of the surface. That chromium oxide layer that's on top of the surface needs to remain there for the stainless steel to work. And as soon as you start stripping off that layer, it's now exposed to different elements. Fluorides is one of the big things that start attacking the metals. And one of the big things for stainless steel is actually microbiologically induced corrosion, where you have sulfur-reducing bacteria, or SRBs, that attack the metal. They form a nodule, a beautiful little home on top of the surface, oxygen deficient, and they start eating away at the chromium, or whatever it is that they like in the actual metal. And what do they excrete? Sulfuric acid. And part of that sulfuric acid actually starts eating into your metal. Or, even worse, finds the grain boundaries of the actual structure of the stainless steel and causes stress corrosion cracking. And that can be a dramatic failure for stainless steel items. What about concrete? What do we mix concrete with? Potash. So we've got ash, we've got soil. Again, we've got all our minerals that's in the soil, and we add water into it. And depending how clean the water is, it might have high chloride levels or low chloride levels. And most of the time, they take the hose pipe and they chuck it in. They don't test the water before they do it. Now you take your concrete and you put some structural steel to strengthen it. What have you got? You actually have a perfect corrosion cell that's set up. Not just that, concrete is porous. So it's going to start attracting all the stuff from the outside as it goes through the hydration process of curing. And as it goes through that process, when it gets to the rebar that's inside, the concrete starts spoiling, and you can actually have degradation. I call it corrosion of concrete, but concrete doesn't actually corrode, it degrades. It breaks down because of the actual build-up of rust around your rebar inside. It starts putting pressure on it, and then you have this type of setup. What about plastic? And I use the word plastic because that's the most common term that people hear. Polyethylene, polypropylene, polysiloxanes, polyvinyl chlorides, polyfluoroethylene. They start adding all of their little acronyms on. My plastic is better than your plastic. No, man, yours is a little bread bag compared to mine. You know, I can put my stuff in salt water. And yeah, but your stuff breaks down when it gets into the sun and it starts going soft. So you've got the competition between all of these manufacturers of plastics. But what affects plastic? You've got UV. As soon as that stuff gets into contact with high environmental conditions, temperatures, and so forth, it can start breaking down certain elements in the actual polyethylene. And polyethylene is a perfect mold release. They actually put it inside things that you don't want it to stick to. So you use polyethylene. What do people do when they do some spray painting? They take a black plastic packet, polyethylene, and they mask it and you paint on it. You can actually take the paint and peel it off. It doesn't stick to it. But there are methods of preparing polyethylene to make items stick to it. Sometimes they induce a bit of flame, heat it, and once it's to a certain temperature, wipe it off with ethyl ketone or tetrahydrofurane, which is some of the solvents that can get used. And now you get a proper bond between your coating system and the actual polyethylene. That's just some of the methods. What about wood? We coat wood. We paint woods quite a lot. What's the most common thing that we put on wood? Varnish. And what is varnish? It's polyurethane or epoxies, depending on what type of system gets used. And why do we do that? Because we want to protect the actual wood from rotting or from mildew or from fading. But again, how do you make it stick to wood? You can't just go to a tree and paint it. You can try, it's going to work for a little while. And you might write your name on it, but going back to the days we used to write, I love so and so. You have to carve it, you have to carve it into the tree in order for it to stay there. But if you put some paint on, come 5 years later, it's gone. But there are methods of preparing the surface. You abrade the surface, you clean the surface, you wipe it down with turpentine or whatever the system is that you're doing. Then you put on your varnish or your paint. Now you can make it stick to the actual substrate. Again, surface preparation is key to making these items last long. So the question really is, how long can I make it last? And I'm sure previous presentations that I've done, I've used the same type of pictures. If you prepare something to last for a long time, like a pipeline, for instance, once that structure is buried, you want to go back every 5 years to dig it up, to make sure the coating is intact? Most definitely not. So they are designed by engineers to last 30, 40, 50, 100 years. So in conjunction with cathodic protection and a coating system, you can protect the pipe. But all you need is one area not to be prepared properly. And what do you have? You have this cathodic disbondment, and it actually drills a hole through the pipe. And if you look carefully at this picture here, you see that little white dot in the middle? That's zoomed up in this image here with a man standing next to it. Luckily, with this picture, and if my memory corrects me, this was taken in Utah, somewhere in the Utah district. The explosion took place. It happened on a Sunday. And these three houses, the three houses in the area, people were luckily at church. Hence, no loss of life. But do you think that could have been more catastrophic? 3 families could have lost their lives in the process of that. And this is just one of the actual failures that have occurred due to improper surface preparation. An inspector went past and said, it's only as big as my nail, so therefore I don't need to go and clean it and make sure it's got coating on it. And what can happen? A huge failure can occur. This is a line that's taken from most of the AMP literature that we get up. Corrosion is a dangerous, extremely costly problem that impacts every industry. Aeronautical, aerospace, biological. You can go into the medical industry, civil industry, electrical industries, mechanical industries. Every single industry that we are involved with, corrosion is affected by. And somewhere along the line, you've got to put some coating on to give it a longer life. And if you don't put the coating on properly, in other words, not preparing the surface or doing proper surface preparation, what can happen? $2.5 trillion a year is spent on repairing work that needs to get redone and redone. So shortcuts is the biggest problem that we find out there in the industry. As an inspector going out on a lot of projects, we find that people take shortcuts. I was talking to one of the guys outside now. It's quite disheartening to speak to an engineer or to a project team and they say, yes, we hear exactly everything that you're telling us. We will make sure that it gets enforced. Thank you very much. And as you walk out the gate, you get a WhatsApp on your phone. Don't worry, the inspector is gone. We can paint now. And it happens out there. Why? Because they're taking shortcuts. But if you take shortcuts, now the cost starts coming in. That $2.5 trillion that we spoke about. Unplanned shutdowns. We don't even have to talk about ESCOM. ESCOM isn't even shy anymore that we talk about them because they know they have a problem that we need to deal with currently in our industry. And that's because maintenance has to keep on redoing the work that was originally not done properly. What is the biggest cause? Surface preparation. Because when they design something and they start building something, you get the civils guy that come in, you get the mechanical guys, the electrical guys, everybody does their work. And everybody falls behind a week. What's the last thing that they do on a project? They paint it. So who gets the brunt of trying to catch up at the end? It's the coating contractors. And they say, oh, don't blast it, just paint it. Nobody's going to see it anyway, it's going to be hidden. So where does the problem lie? Surface preparation. And that's why it is so important. The loss of product and time, environmental impacts, never mind the factor of the loss of human lives. And this is the biggest problem that we hear out there in the industry. There's never enough time to do it right, but there's always enough time to do it over. How many people say, and unfortunately, here guys, don't worry, I'll get phoned again to come and redo the work. So they've got to pay me again. And everybody is guilty of that. Well, hopefully not the corrosion engineers, because we don't fight against it. But the point being, a lot of people are pushing because they don't want to go and do the rework. And this is the type of thing that we see out there in the industry. Oh, it's bolts and nuts. I don't need to paint bolts and nuts. Wait until the bolt fails. Now what we've got. What about thin coatings or painting over rust? Oh, nobody's going to see it. I'm going to cover it up. Maybe crevices. Again, nobody's going to see it. Why do I need to paint them? It emphasizes the point again about the importance of doing the surface preparation right from the beginning. So with that being said, how are surfaces cleaned? We can use manual methods of cleaning. So you use degreasers. Maybe you can use some form of water jetting, which is becoming more and more common in the industry, especially with rework that's being done. You get new systems out there that's available. This is just a little video that shows the new type of robotics that's available in the industry. If it wants to play. It's not working with me. Anyway, the point being that's a robot, and as the robot is going, it basically sweeps as it's going across the surface. This is just some of the new methods that's available out there in the industry. See if we can get it to work, because it's quite a nice little clip. I think it's being stubborn. I think there we go. And that's new methods out there. Now people that's around safe, and they can actually do it in areas where you now not require working at heights, and we can go through all those things. And it becomes a big thing in industry. But I couldn't get there because my working at heights permit actually expired 2 days ago. So there are methods out there. Instead of saying, oh, well, then let's just leave it and let's just paint it. You can actually use other methods to prepare the surface properly. Sandblasting is the most proper one, and I use sandblasting because that's the most common word, but grit blasting or using grit. You see a lot of people here from blast right? And you get different type of abrasives for specific surfaces. We spoke about stainless steel, aluminium, and all of those others. You can't just use one type of grit on any metal. Some of them are pretty generic that can get used everywhere, but sometimes you need specialized products that you need in certain areas. But again, speak to the people that know about it so they can provide you with something to do the surface preparation properly without having the failure. And then obviously you can use hand tools. And some other times they don't. Polishing the surface, as you polish the surface, it can actually cause a problem. Now this is just one of the methods that we use out there in the industry. Out in the industry, there are standards. And if we follow these standards of surface cleanliness and we inspect it properly, that's one way that we can make sure that surface preparation gets done the right way. Pre-preparation, that's just some of the standards that's available for NACE and for SSPC. Last cleaning standards, NACE number 1 or SSPC SP5. And here we might be more common to using SA, visually clean steel. The biggest problem we find out there in the industry is people don't understand the standard, and they don't know how to interpret the standard. They mix standards. They call it SA3 white metal blast cleaning. It's 2 different standards. You're not applying the right method. And this is where training becomes an essential And here at the Institute, we provide that training to get the people to understand these are the different standards. If you want to know more about this, come on one of the courses and we'll show you. Okay. So last but not least, instead of using the line, well, I don't need to worry about it because there's always enough time to do it over. Here's my catchphrase. I believe that there is enough time to do things the right way the first time. How do we do it? By doing proper surface preparation. That's not a, it was a photo of me when I was much younger. As you can see, a little bit of hair pointing. We need to have more detailed methods of cleaning. And if we pay enough attention to cleaning the surface properly, we can apply a coating on top of it that will last for many, many years. And if we do that, things will last for a very, very long time. If they coat it properly, by putting it over surfaces that were prepared properly, we can have pipelines that last hundreds of years. You go into aeronautical space and nobody wants anything to rust in their mouths. So we can even use it in the medical fields to make sure that the preparation gets done properly. And funny enough, when your cavities and things start falling out, guess what's the reason? The dentist didn't clean it properly. So again, surface preparation. If you did surface preparation properly, that filling that you had won't come out. So with that being said, that's all I have to talk about surface preparation. And I hope that was a little bit insightful just to see how important it is that we do proper surface preparation. Thank you very much. Any questions? I'm scared because Dave told me he gave somebody some insight to give me a hand today. So any questions that you need to direct Dave, he's only the president who answered for us. No, any questions?
Just how to remove all building.
Now that's a big question, and we actually had that question asked to us not so long ago. They said, well, you can go in there and you just chip it off. But the only effective way to actually move it is to get it to a surface that is thin enough so you can burn the surface. And once you've actually burned that surface clean, then you've got to blast, burn again, blast until you have removed all the bitumen. It's very difficult to remove bitumen. It will take ages.
Ultra pressure.
Very
successful.
Yeah. Ultra pressure is one of the methods that gets used very well. You can get it and lift it up. But we typically find that some of the bitumen still remains in the pores of the actual profile. And that's with flame cleaning. And if I may, if you just go back to this little chart, you actually have a standard SSPCSP4, which is flame cleaning, and ISO FL. It's a standard that was developed for flame cleaning. It's used in the pipe mills quite a lot to fracture mill scale before they actually put a coating on. But it can effectively be used to remove bitumen once you've taken the excess off and you remain with only the pits that's in the bottom of the voids.
What about liquid nitrogen?
You can freeze it. A very, very effective way. If you can get it cold enough, it fractures. It actually falls off the surface of blocks. So, which is one of the reasons, and now just going to this picture where we've got it out in the icelands, you get coatings that people specify here in South Africa or areas where they know bitumen can work very well. But the installation gets done in an area that's super cold and it's not going to work because now your bitumen freezes and it actually, like glass, it just falls off the actual surface. That looks like it. Right. Thank you very much. Ah, there we go. One more. Great.
To follow standards of cleanliness on the planet.
Yeah, and you've got a standard here that was set aside. This NACE number 6, SSPC SP30, is a standard that's used for concrete cleaning, and it uses methods of what they call brush-off blast cleaning. So at an angle about a meter away from the surface, you make sure that you remove most of the efflorescence and the natives. Thank you very much. Which is your salts and things that actually migrate to the surface. But then another effective method is acid etching. So you actually use acid to etch off most of that asphalt off your surface. And once you've done acid etching, again, you need to neutralize before putting a coating system on. But there are methods of effectively cleaning concrete to get a profile. And in scarifying, That's one other method that they use. Like a polisher that you use for polishing floors, it's actually got tungsten bits at the bottom, and it actually scarifies the floor to give you a profile. And then it's a washing and cleaning, so you get your anchor profile and you put your coating. Yes.
What for Australia?
Sorry.
Australia.
It's so brittle that you've got to be very careful how you prepare it. So most of the porcelains get cleaned with either an acid that they just etch into the surface, or they use a solvent. You can effectively clean it with solvent and then do your painting if you need to know also. But porcelain is so dense that a lot of times, or some of the porcelains are so dense that you don't need to put a coat. They bake it to the place, to the point that you've got a glass finish, like a plate or a cup, which is typically made of porcelain. And once you've got that baked effect on the top, it provides your protection into you. Again, flame cleaning, it's a method of flame cleaning. Yes.
The way when I use the suffix tolerant coating, why do you like to clean that perfectly when I use it?
If you've got rust underneath the surface, it actually forms a film. And if you put a coating on top of that rust film, the coating sticks to the rust film and it doesn't stick to the substrate. So you get certain degrees of what they call flashback. So going back to the standards again, you can actually follow these standards, WJ, water jetting to bare metal, very thorough and light water jetting. And they specify the amount of rust back that you are allowed on the surface, either being light, moderate, or heavy. As soon as it's heavy, you don't put a coating on. You want light to moderate. And that's where the guys who do the paint sales will tell me they don't want anything more than a moderate. They see anything more than a moderate, you don't want it on. And you test with it with a cloth. So you take a white cloth and you wipe it over the surface. If you see rust on the cloth, it's not going to stick. That's too heavy. You need to move it over the surface so you see minimal flashback that actually comes back onto the little cotton swab. That's your question. Right.
So it's a subjective measure when you say moderate or.
It's a visual. These are all what they call visual standards. And what's nice about these, what we have done now recently, you'll see I've added into this chart here the actual percentage that you allow. So they have a surface area that you measure, typically is 10 square meters. And in that 10 square meters, you evaluate the 3 inch by 3 inch, 75 mil by 75 mil area. And that area is not allowed to have either nothing or 5% or 33% of flashback that is allowed on the surface. Yes.
So with sandblast surface and grain, how do you paint?
Problem with rain is what did it catch going down? So you can have severe contamination of sulfur. Sulfur and nitrate deposits of rain is one of the, obviously down by the coast, chlorides. So when it rains, you've got to test your surface. If your surface is clean enough, once you've done a soluble salts test, testing for chloride, sulfates, and nitrates, you can, and there's not rust back that you can wipe off. Safe enough to, most of the time, you'll have the guys let it rain. When it's done, clean off the water and do flash drops. Test again and put your coating. So that's one effective way. Right. Thank you very much.
The time frame, according to the name, what is the time frame from finished blasting?
It really depends on relative humidity and surface temperatures. So if your relative humidity starts getting close to 85% relative humidity, most coating suppliers is going to tell you, if it gets to 85 or above, no coating takes place. And now the time frame shortens. If it's between 80 and 85%, you might have 1 hour to put a coating on. If it's between 75 and 80, you might have 2 hours to put a coating on. If it's lower than that, then they tell you 4 hours, 6 hours, or whatever. So that should, and I'm saying should, I'm winking at the coating suppliers, should be put in the product data sheets that they tell you when the relative humidity is between these brackets, that's how long you have to put. But it's temperature and relative humidity dependent. So there's no real given. A good thumb suck in the industry, they tell you 6 hours. but now you've got a polyurethane coating, and that polyurethane coating has to be put on the surface within 3 hours. So now you've got 3 hours. After blasting, you've got 3 hours to put it on. So it's dependent on product to product. And that's where the coating suppliers working with the contractor is very important to say, don't blast a 400 square meter area and trying to put the coating. Do 10 square meters, paint it. Do 10 square meters, paint it, and so forth. If it's a difficult system to work with. Am I correct in saying that?
100%.
Does that answer your question?
Next question.
Yes.
Assets. So,
Yes.
11 PE. Which one is the worst?
ISO 12944 is the 2018 version of that standard. Has actually been revised to recategorize certain industries. And you'll be surprised to know that Secunda and areas right inland has got a higher corrosion potential than what you have down at the coast. So there is a chart. It was developed by the RAL. Remember, the RAL has got a chart of South Africa that shows corrosivity, but she's actually reworking that at the moment, from what I understand, because the areas have changed so significantly. But you're quite right. You get different regions that has got higher corrosivity levels due to whatever it is that's in the air. I'm thinking of Richards Bay. Richards Bay with the coal trucks there now. The amount of sulfur that's in the air is ridiculous. You drive in there with a clean car, an hour later it's black. That's the amount of, and that's just from the actual residue that falls on top of the car. Now you go to PE, and you're close to the ammonium factories, and you've got that ammonium deposit that comes along. You can actually see the paint peeling off on certain of those vehicles. Go to Cape Town. This side of the bay, there's nothing. It's good. The guys paint. Go to the opposite side of the bay, which is maybe 500 meters away, get chloride levels that are so elevated that you need a higher concentration of how you prepare the surfaces in that area.
Make a statement. So yes or no. But if I think, especially it's a big area to part. A lot of people doing protected buildings. What the people don't understand is that 2 factories on, down or up, still using assets. Still.
Yes. Short answer. If you've got galvanizing facilities that's quite close to you, remember one of the elements that they use to clean your steel. We didn't talk about galvanizing in this session, but one of the surface preparation methods or surface cleaning methods used on galvanizing is acid etching. So they actually put it in hydrochloric acid or sulfuric acid to take off all the mill scale and all the greasy. Then it goes to a neutralizing station. Then they might do it a second time or a third time. That acid would 100% correct. And those factories go and look at their galvanized sheeting on their roofs. Most of them are corroded to hell and gone. And depending on the wind direction, there's one factory, I'm not mentioning where it is, it's in South Africa, in our borders, let's put it that way. The factories on the left-hand side of it, there's no problem with corrosion on the roof sheeting, because the predominant wind goes the eastern direction. All the factories just downstream of where that galvanizing facility is corroded to smithereens. They've got higher levels, which require more cleaner or a cleaner surface before putting coatings or replacement. That's how severe it can get.
If I say I can confirm what you say, if you drive through industrial area, you see that some roofs is rusting. There is a high activity of assets in the area.
You'll find it next to railways. We find it quite a lot. If you've got your steam train and your diesel locos that get used. There was a place in Stilfontein. I'm taking the northwest, for instance. That's not even Gauteng. It's a rural area, Stilfontein. You would think, corrosion isn't that bad. All the houses right next to the railway line, because they don't have electricity anymore, and they switched over to diesel units. You can see what those roofs look like. Because of the fallout of the diesel on top of the roofs, you get rain, you get a concentrated cell with higher acid levels. So yes, you will find it in those areas that it is high.
So I reference back to the one video where you have the against the plant. Last, you say that you need to have the area in between 85, 70, between 75 and 85%.
Maximum relative humidity is 85.
There's still a high dust factor.
Dust and debris still gets removed. You have to remove it. And again, that's where the time factor comes in with a lot of these. When you clean that surface, once you've cleaned it with the water and it dries, or once you've blasted the surface, you need to remove the dust. And the most effective way to remove dust off a surface is vacuuming. You actually take a vacuum cleaner and you vacuum the surface to get the dust off the surface. And years where coating contractors cut corners. Now I just take the hose from the blasting pot and I just go and just blast most of the dust off. It works, but what happens to the dust? You're actually lifting it into the air and it just deposits back on the surface. So vacuuming to get rid of it is more important.
It's not only that, because one that you have, we have a lot of fuels. There's a lot of steel dust. You can blow it, you can blow,
And it gets
just stick back.
so there's a
Loose particle.
is
One factor.
easy method to fix that. Get yourself a rectifier and you charge your pipe negative. Get a battery connected to it. All that you need to do is take your actual substrate. If you know that it's attracting it, take it to the opposite value. You can connect the battery to it, like Dave was saying, or you just earth it. And by earthing it, you're creating an area that's less static. You're removing the static of the actual area that you paint. And that's one way that gets used.
You don't have that.
You don't have it.
Everyone is nowhere in the world.
You do. A lot of guys use it in the motor vehicle industry. That's exactly the method that they actually use to get the paint to stick. They charge it the opposite way so that it works.
You know,
to electroplate, another way of channel. And then it's got a long definitely positive, but the technology actually
Does exist.
I think it's not easily available, currently available, and it takes for the engineer and understanding the situation. It's very
We had an instance, for instance, that was so simple. It was, okay, they were doing pipes and they kept on having the same problem that you mentioned now. The stuff kept on sticking to it. So we told him, take a piece of zinc, just find a piece of zinc and a copper wire and connect your zinc, let it lie there on the floor and take that to connect it to your pipe. What you've done now, in a small area, you've created an anode and a cathode. You've made the pipe more negative compared to the area next to it. And they were able to apply the coating sufficiently. It's just a bit of ingenuity, but it can be done.
if I can say, can this confirm, yes or no? So it sounds like.
No problem.
It's even right to say that when that thing item is lost, and like immediately.
The sooner the better. The always to norm is the sooner the better. Not just is your surface chemically active, and I use the word chemical very loose now, but it's not just chemically active, it's an active surface. So it will make the coating stick much better. And it's cleaner. Flash black, the rust, the deposits of salts, everything else is far less. You reduce all of that. So yes, the quicker the better. With all the dust removal.
So, years ago, Alan Lyle, when he was at ESCO, produced a paper on the survey, exposure survey he'd done on Western power stations. And the results were a big wake-up call for everybody, because the thinner coatings applied to wire brush steel lasted better than it lasted equivalents. The reason was the peak cover, the cover over the peaks, and the spool railways used to use wire brush systems, but multi-coat with MIO primers and that sort of thing. And they last for many, many years. So I just want to emphasize that if you haven't got enough cover over your peaks, watch out for plastic.
You 100%. And if I may add to that, that's why the latest technology that they use now in actually measuring surface profile is what they call a peak to valley count. So the amount of peak to valleys that you get over a certain square area. And the gauge manufacturers, each one has got these different gauge that will actually show you an image. And some specifications that are written actually have a minimum peak to valley count of 40,000 or 20,000 per square inch, so that you have exactly what you're looking. So I wasn't aware of that study that was done. It was very interesting to know that.
The other point I want to make is that the vast tonnage are similar to galvanizing. You remove the acids, the rust acids, and then neutralize it and then phosphate it afterwards. And phosphating is an excellent preparation for other coating, other kinds of coating.
I mean, the main reason for it is to remove that oxygen. As soon as that oxygen is close to the surface, whatever coating you put over that, you've got oxygen at the bottom. And as soon as you've got moisture that diffuses through the coating and it gets to the oxygen, again, oxygen and moisture is the two killers when it comes to corrosion. Thank you very much, everybody. Really appreciate it.
Can't you misunderstood? I've answered the most questions that gets the point.
Yeah, well, yeah.
Thanks, thank you. Well, that should be very much.
Thank you.